Okay, let's consider this problem. This problem is the vibration problem. That is we have the spring and the mass like this, and from this we may form the equation of motion. That is may write in this form. Okay, equation of motion is right in this form. That is we define KOM like omega square. Okay, now we starting with determine the natural frequency of the system first. For this problem, we need the constant K that is not given directly for the problem. We have to consider the problem that is give us that a spring is stressed 100 millimeter by 20 kilogram block. It means that at the equilibrium state, okay, the spring deform, okay, from the unstressed position. Okay, the spring has a deformation ys equal to 0.1 meter. Okay, at this point. Okay, and from the free body diagram at this point, we have this is the spring force at equilibrium position is balanced with the weight. Okay, so from this equation, we can determine the constant K by mg over ys. Okay, so then K is equal to mg over ys, that is this term. Okay, so the group 7 maybe give the detail of this when in the exam also in order to reduce the confusion. Okay, to this step we already have K equal to 1962. Okay, and we can determine omega equal to 9.90454. Okay, use 5 digits. I recommend you use 5 digits because it's the calculation is maybe a lot of error when you do not keep the digit, the 5 digit like that. Okay, and from this equation, okay, we know that the general solution is become like this. Okay, this is the general solution. Y is equal to A sine omega t plus B cosine omega t. We have two constants. We require two initial value. Come back to the problem. Okay, the problem is given the initial value already. If the block is displaced 150 millimeter downward from its equilibrium position and given a downward velocity 1.5 meter per second. That is mean that when time equal to 0, okay, y become 0.15 meter. So then this is y0, right? And velocity is 1.5 meter per second. That is, this term is become v0. Okay, so then we have two initial conditions. Okay, initial condition is t when t equal to 0, y equal to 0.15, and v0 equal to 1.5. Okay, so according to this, from the first equation, that is when we substitute time equal to 0 to the first equation, we obtain y equal to 0.15. Okay, and sine term is become 0 because sine 0 becomes 0, right? And we have just only cosine term, that is cosine omega t becomes 0, cosine 0 become 1. So then we obtain the constant b equal to 0.15. Okay, and after that, we take the first derivative to this equation, we obtain y dot, and y dot is v, okay, velocity. And velocity term is composed of a omega cosine omega t plus b omega sine omega t, right? Okay, sorry, minus b omega sine omega t. Okay, from this term, it's we substitute time equal to 0 also. That is okay. This I found the mistake for this group. Okay, this group, the mathematical term is maybe something like this. The 0 is not over here. This is omega. Omega is not 0, but 0 is t. T becomes 0. Okay. It should be omega, that is 0 instead. Okay, please correct it. Okay, please correct it before sharing. Okay, then for this we already solved for the constant a, that is 0.15144. Okay, don't round off this term. Okay, it is not equal to b, right? It is 0.15144. Okay, so then we can complete the solution like this. That is a sine omega t plus b cosine omega t. That is all right for this case. And for the phase angle, phase angle is equal to arc tangent b over a. Okay, arc tangent b over a. At this stage, you can answer this as the degree. Okay, 44.72630 degree. That's it, all right. This is the okay. If the solution is like this, that's it, all right. That is all for this step. Okay. But for some case, you may answer the alternative solution. For alternative solution, okay, which means that you would like to determine the amplitude also. That is a square plus b square, right? That is equal to 0.15144, right? Square plus 0.15 square. That is maybe equal to, okay, for this, we may have C become 0.21316 meter, okay? So then alternative solution is maybe like this. Y is become amplitude, that is 0.21316, okay? Sine omega, that is 9.90454 t, right? Omega t plus 3, okay? At this point, if you answer like this, it is completely not correct, okay? The angle, when you use with the formula like this, you have to change it to radian before, okay? So then angle phi is 44.72630 degree. You have to convert it to radian first. This angle in radian, we know that 180 degree is pi radian, right? So then 44.72630, it should be what? It should be 44.7263 pi divided by 180, okay? So then we have is equal to 0.78056, 0.59 radian. So this term should be 0.58059. Okay, it has to be in radian. Okay, do not substitute the angle in degree in the formula. Okay, you have to note that like this. Okay, that's all. That is complete of this problem.